to our video on the GCF, which equals the greatest or largest common factor. What does that mean? Well, what's a factor? Let's look at 12. Well, 12 equals what? 1 times 12, 3 times 4. Oops, why did I do that? I'll do. When I set this up, by the way, I'll just share my way of factoring. I think of this as like some type of rainbow method, and we have 1 times 12 to set my outer bounds of my factors. There's my biggest and smallest, and then I take the next biggest over here, which is 2 times 6, and then 3 times 4, and then once I reach two factors that are right next to each other, right, two consecutive whole numbers, I know I'm done factoring. So for 12, the factors go 1, 2, 3, 4, 6, and 12, and this is a nice order to set up our factors because we're arranging them from smallest to largest value. And if we're looking for the largest value, as we are with the GCF, this format will tell us the answer. The thing is, though, we need a second number to compare 12 to. Let's compare 12 to 8. So the factors of 8 are 1 times 8 and 2 times 4, right? And 3 doesn't go into 8 evenly, so we're done. So what is the largest factor they both share? They both have 1, they both have 2, they both have 4, but they both don't have 8. So 4 is the largest common factor. So the GCF, you would say, of 8 and 12 equals 4. That's the biggest factor they have in common. And these factors are just numbers that multiply to give us these numbers. So what's that biggest number? And there are other ways to do this, which is nice, right? Because there seems to always be at least 2 ways to solve a math problem. And that just is nice, because what if you don't like the first way? Well, the second way, we can look at the prime factors. So prime factors, all right, will tell us everything we want to know about the GCF, and as we saw in our last video, the LCM, right? Least common multiples and greatest common factors. Let's look at the two numbers, 30 and 45. If we write these factor trees out, 45 is 3 times 15. Circle that prime number. 15 is 3 times 5. And now we have our prime factorization of the number. 30 is 2 times 15. 2 is prime. 15 is 3 by 5. So we have 2 by 3 by 5. Now your goal here is to look for the largest factor they have in common. Well, 30 is made from 2 times 3 times 5, or 3 times 5, right, which is 15. So is 45. 45 is 3 times 3 times 5, but what do they have in common? Well, the largest pair they have in common is 3 times 5. So the greatest common factor, the GCF of 30 and 45, just equals 3 times 5, right, or 15. And that's really all there is to it with the GCF. Let's look at a couple of other examples. So in that example, we had two numbers, and we can change this around. Let's look at some other examples. What about 14 and 49? What's the GCF here? Well, 14 equals 2 times 7, and 49 is equal to 7 times 7. What's the greatest common factor? Well, 14 is made from 2 times 7. 2 times 7. 49 is made from 7 times 7. But what do they have in common? Well, the largest factor they have in common is just 1 7. So the GCF of 14 and 49 just equals 7. And other examples we can look at. What if we had 15 and 75 and 30? What do we do when we have three numbers? Well, I mean, same strategy. 15 is equal to 3 times 5. 75 is equal to what? Well, I would say 3 times 25. 3 is prime. 25 is 5 times 5. And 30 is equal to 2 times 15. 15 is 3 by 5, right? So 2 by 3 by 5. So I'll write these out. 15 is 3 by 5. That's my separating line. 75 is 3 times 5 squared. And 30 is 2 times 3 times 5. So how do we figure this out? Well, what do they have in common across the board? They all have a 3 times a 5. Right? Somewhere, in some order, even though they might not be in pairs, they're spread out to get that number. So what does that mean? Well, it means the largest common factor, or GCF, of these three numbers is the largest pair they have in common, which is 3 times 5, or 15. And that's the basic idea of the greatest common factor. In the next video, we'll look at two larger numbers. Alright, thanks.